this video, we are going to talk about consistency between applications which are replicated with DataGuard or any other form of asynchronous replication. We're going to show you 1,000 miles replication with DataGuard max performance over between two exadatas in the primary and disaster recovery site. It does not have to be an exadata. It could be a regular Oracle server. It could be that is attached to storage, that has storage. It does not have to be DataGuard. It could be any storage replication, any means, any form of replication that you would like, that you're using. But it is asynchronous replication as it is across 1,000 miles. Now, consistency is very important for a fast, swift recovery. Because if you don't have consistency between applications, let's assume you have a manufacturing application and an inventory application. Now, manufacturing needs to know what the inventory is in order to draw items from the inventory and for manufacturing. Everything has to be concurrent. The state of your assembly line is dependent on those two applications being concurrent and consistent. If you are replicating the two databases and you're replicating with two different streams of DataGuard max performance, they are not consistent. Those two DataGuard, basically you have two applications. You have application/database 1 and you have application/database 2 and so forth. Now, these databases are replicated with DataGuard max performance with DataGuard 1 and DataGuard 2. They are not the same DataGuard stream. They're not the same software instance. When you're replicating both of them or more that should be consistent, if you want to fail over, you have to have everything consistent. Otherwise, it's not even a matter of time. You would have to have all of them consistent with each other in order to be able to fail over. So if you have those two or more DataGuard streams, when you have a disaster, let's say this one is minus 30 seconds. The data here is minus 30 seconds. This one here is minus 45 seconds, which means that the image of the database, the transactions that are safe and sound in this DR site, inside this exadata, are 40 seconds, 45 seconds after the reality or the true time of the disaster. So there was one strike of disaster here, but you have a lag of 30 seconds here and 45 seconds here, which means those two databases are not consistent. They don't see time, they don't see reality at the same time. Which means that if you need a one very well-oiled machine of an assembly line in the other side, you don't have it because the databases are not current. This poses a real challenge because what you would have to do is now go back with each, and imagine you have more databases here. You would have to go back in time to a place, to a snapshot, to a place in time or a point in time where all of them are consistent. So it's not going to be 30 or 45. You will need to find where exactly all of them. That could be minus 337 seconds or more. That all of them have a point in time where you can recover to. So you lose much more. It will take you hours and hours and hours to find that point in time. Otherwise, you would not be able to fail over. Now, what if you had synchronous replication? What if you had zero data loss? So here's the thing. Zero data loss means 0 seconds here and 0 seconds here, and so on and so forth. Which means you have a consistent point in time because you have synchronous replication of all of your applications and databases. They're all exactly stopping at the same time, and you can recover them at 0 seconds lag. So no reconciliation, no finding that point in time where all of them are consistent. It's all consistent because they're all at 0. Now, how do you achieve 0 data loss at 1,000 miles? So you do that with Axxana's black box. So we have Axxana's black box, and we have all of these databases separately multiplexing their latest and greatest redo logs and archive files into the black box. So redo 1, redo 2, redo 3. Now all of them are at 0 because Axxana keeps all of that. Axxana does not have a lag. Axxana keeps all of those latest and greatest. And when you transmit the data after a disaster, when this is all gone, and this is all gone, and you transmit the data over Axxana's wireless communication, VPN protected, all of them are going to the same, basically in one stream, going to the same exadata, all of those databases and applications, because we protect multiple databases and applications, are going to be transmitted. Each one, each application, basically number 1, number 2, number 3, they're all going to be at 100%. And when they're all at 100%, they're all concurrent. If they're all concurrent, you do not have a lag in time. You do not have a time to reconcile. You have 0 data loss, you have synchronous replication, you have the fastest recovery time because Axxana offers you full consistency at 1,000 miles over asynchronous replication. So this was the video about how Axxana protects against consistency issues in asynchronous replication between multiple databases and applications. Thank you.